Hello student, in this video lecture I am going to obtain the mode of Poisson distribution and examples on it. Now, how to obtain the mode of the Poisson distribution? Mode of the probability distribution is the value of the random variable x at which PMF is maximum. Okay. Now, for Poisson distribution, if x follows Poisson distribution with parameter m, then its probability mass function is probability of x equal to small x, which is equal to e raised to minus m raised to x upon x factorial. X takes values 0, 1, 2, 3 up to infinity. 0 otherwise 0, otherwise here m is greater than 0. Okay, now probability of x upon probability of x minus 1 is equal to, we take ratio of p of x upon p of x minus 1. P of x is equal to this one, that is e raised to minus m raised to x upon x factorial. This divided by e raised to minus m raised to x minus 1 divided by x minus 1 factorial. Okay, this is the ratio of p of x upon p of x minus 1. Now here e raised to minus m gets cancelled, then m raised to x gets cancelled. Now the remaining terms are x minus 1 factorial, this term goes to the numerator, upon this x factorial. Okay, then the m raised to minus 1, this term goes to the numerator into m. Now we convert this x factorial into x minus 1 factorial as, this is x minus 1 factorial into m upon x into x minus 1 factorial. X factorial is converted into x minus 1 factorial. X minus 1 factorial, x minus 1 factorial gets cancelled. Then remaining terms are m upon x. Okay, this is the p of x upon p of x minus 1. Okay, this ratio is equal to m upon x. Now the value of the parameter m may be integral or fractional. We shall obtain the value of the mode in both the cases, if m is integer or m is fraction. In that case we obtain the value of parameter m as follows. Now we consider the first case. Case 1. M is not an integral, that is m is fraction, m is fraction. Okay, suppose this is equation number 1. Okay, then in case 1, by using this equation 1, the ratio p of x upon p of x minus 1, which is equal to m upon x. This is greater than 1. This ratio is greater than 1 if x is less than m. Okay, that is x takes values 0, 1, 2, dash 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 up to box m. Okay, now here box m represent where this box m represent integral part of m, that is the integer part of the m only. The box m is the integer part of m. Okay, then in this case, now probability of x is greater than probability of x minus 1 for x equal to 0, 1, 2, dash 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 up to box m, or probability of x minus 1 is less than x for x equal to 0, 1, 2, dash 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 up to box m. Therefore, if we substitute here x equal to 0, okay, then we have p of 0, then we have p of 0 is less than p of 1 less than p of 2 less than dash 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 less than p of box m. Okay, suppose this is equation number 2. On the other hand, we have this ratio p of x upon p of x minus 1 is equal to m upon x is less than 1 if x is greater than m by x. This ratio is less than 1 when x is greater than m. Okay, Then therefore in this case P of x is less than P of x minus 1. P of x is less than P of x minus 1, or P of x minus 1 is greater than P of x. This can be written in this way. For the values of for x equal to box M plus 1, box M plus 2, and so on. Okay, then therefore probability of box M, this probability is greater than, this is greater than probability of box M plus 1, this is greater than box M plus 2 greater than dash 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 dash, that is so on. Okay, suppose this is equation number 3. This is equation number 3. Now from 2 and 3 we have, from 2 and 3 we have probability of 0 is less than probability of 1 is less than probability of 2 is less than dash 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 probability of box M, this is greater than probability of box M, this probability is greater than probability of box M is greater than probability of box M plus 1 greater than dash 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 dash. Okay, then if M is not integer, then its integer part is the mode. This M is not integer, in that case its integral part is the value of the mode. Okay, this is the first case. Now we see the second case, that is M is an integer. If M is integer, in that case how to obtain value of mode for Poisson distribution. Okay, now see case number 2. Case 2, M is an integer. M is an integer. Then note that probability of x upon probability of x minus 1, this ratio, which is equal to what? M upon x. This is greater than 1 if x is less than M. Okay, then this ratio is equal to 1 if x equal to M, and this ratio is less than 1 if x is greater than m. Okay, now like case 1, this can be written as p of 0 is less than p of 1 is less than p of 2 is less than dash 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 less than p of m minus 1. This is equal to probability of m is greater than probability of m plus 1 is greater than probability of m plus 2 is greater than, so on. Okay, in this case the PMF reaches maximum at x equal to m, that is p of m is equal to p of m minus 1. Okay, hence PMF is maximum for values of x at m and m minus 1. Okay, thus when m is an integer, there are two values of the mode, namely m and m minus 1. Okay, in this way we can obtain the mode of the Poisson distribution. Okay, if m is integer, in that case there are two modal values, m and m minus 1, and if m is fractional, in that case the mode is the integer part of the m only. Now we see one example on this. Suppose x follows Poisson distribution with parameter 3.4. X follows Poisson distribution with parameter m is equal to 3.4. Then the modal value is, mode is equal to, here m is not integer, that is here m is fractional. In this case the mode is the integer part of the m only, that is here mode is box m, which is equal to, m is equal to 3.4 and its integer part is 3 only. 3 is the mode of the given probability distribution. Okay, in this way we can obtain mode of the Poisson distribution. Thank you.